This is AQA A-Level Chemistry. We are on the bonding topic from year 12 and we are now on video number 6. In this video we're going to take a look at shapes of molecules and we're going to start to look at the key principles that underpin it. So much of what we're going to learn on this video or remind ourselves of on this video is factual recall. You simply have to know the names and the bond angles. And then once we've got that, we can move on with confidence to apply that knowledge to some of the more complex questions. As always, I'm going to recommend that you pause as you go, have a go at the activities, and then you can see how you've done as we go forward. So we start with the objectives. We need to know what the rules are that help us to determine the shape of simple molecules. We need to describe how electron pairs around an atom affects the shape of the molecule, the number of those, and we also need to know what the difference is between the impact of a bonding pair and a lone pair. And in the first instance, this table is very, very important. And this is what I was talking about with factual recall. You need to be able to fill in this table from memory. So have a go at it now and see how you do. I'm going to start by drawing my shapes in. I've got my central atom and you can see with 2 bonding pairs I've got 2 bonds coming away. You can see with my 3 bonding pairs I've got my 3 here, I've got my 4 here. We've got a little bit of a difference with how we're drawing that. Same as we can see here, this is a 3D structure that I'm going to talk about later. And finally, when we get down to 6 bonding pairs, we have the shape that you can see here. Now, in terms of the names of these, the top one is linear, and you can see why. The second one is trigonal planar. And trigonal planar, trigonal, 3 points, and it's a planar molecule. It's in one plane. If I turned that 90 degrees, it would be entirely flat. If I look at 4 bonding pairs, the shape that we have here is tetrahedral, tetra for 4. And what you've actually got, if you join up the points, and that's quite badly drawn, but you have got a 4-sided shape when you join up the points that you can see. So there is one side as an example. Trigonal bipyramidal, the name for 5 bonding pairs. And again, I'm not going to draw this one, but you can see that there is a, if I draw around here, in fact, I will have a go. If I draw around here, and then I can go up and up and up, you can see that I've made a pyramid. It's a 3-point pyramid, hence trigonal. But there are 2 pyramids because there's the one below as well. So what we have is trigonal bipyramidal. And the final one with 6 bonding pairs, which often seems a little bit odd, is octahedral. But that's because if you do the same as we've done here, you end up with an 8-sided octahedron shape. So we've got the shapes, we've got the names of the shapes. You also need the bond angles. You've got to know them, remember them, learn them. We've got 180 degrees for linear. Again, that's quite logical. It makes sense. Trigonal planar, if we think about these in one plane, 360 all the way around, it makes sense that it's 120. Once we get to tetrahedral, we're having to start to think in 3 dimensions, and the bonding pairs are pushing themselves as far apart as they can get. This actually takes us down to a bond angle of 109.5 degrees. On the trigonal bipyramidal, you actually have 2 different bond angles. We've got 120, and you can see that here, and we've got 90, which you can see here. And then finally, in the octahedral structure, we have got bond angles of 90 degrees. So this table, you have got to know every part of what is written down here. If you don't remember it, you're not going to be able to apply it to the questions you're likely to see in the exam. So let's have a think about how we have shown 3D structures. And I'm going to start you off by drawing methane. What are we showing with what we've drawn? Well, it's important to say in the first instance that these lines are in the plane of the paper. But actually, I've got this wedge, and that indicates it's coming out of the page, and I've got my dotted or hatched line, which indicates going into the page. And we start to get this idea of it being three-dimensional. So what we're actually going to do is take the knowledge that we have, take the ideas that we've discussed, and see how we can do drawing out the structures, naming the shapes, giving the bond angles for a range of examples. So again, I'm going to recommend you try these, pause on each one and see how you've done. BeCl2, give it a go. So where I'm going to start is to say that beryllium is in group 2. That means it has 2 electrons in its outer shell. Now when you draw that, you end up with this. I've got my bonding pair and bonding pair, so I have got 2 bonding pairs. The ones around the chlorine I've filled in, but they aren't necessary to work out the shape. You might also be thinking it's a little bit odd that beryllium, a metal, and chlorine, a non-metal, are bonding covalently. We don't go into the chemistry of this in A-level chemistry, but beryllium chloride is predominantly covalent. Now, if I've got 2 bonding pairs, I go back to my table and I know that my shape is linear. And if I know that it's linear, I can draw it as a linear structure. And if it's linear, I know the bond angle is 180. So now let's try another example, BF3. And I've started you off. So boron is in group 3. It's got 3 electrons in its outer shell. And when I then draw out my dot cross structure, my boron has got 1, 2, 3 bonding pairs. So my 3 bonding pairs takes me back to the table that it's trigonal planar. And if it's trigonal planar, I draw it in the way that I showed it in the table, and I know the bond angle is 120. Next example, CH4, which you've already had a little bit of a hint of. So for this one, carbon is in group 4, which means it has 4 electrons in its outer shell. So I have drawn out my 1, 2, 3, 4 bonding pairs around the carbon, around the central carbon. And if it's 4 bonding pairs, 4 pairs of electrons, that tells us from the table we've already discussed that the shape is tetrahedral. And if it's tetrahedral, the bond angle is 109.5 degrees. So let's look at another example. I've got nitrogen, or NH4+. Now nitrogen is in group 5. I've got 5 electrons in the outer shell. And you can see that what we've got here, and you've seen this in the coordinate bond topic, there are my 1, 2, 3, 4, 5 cross electrons from the nitrogen. This is a dative covalent or coordinate bond to an H+ ion that has no electrons of its own. Because the NH3 is neutral and the H is positive, overall the ammonium ion has a +1 charge. But in terms of shapes of molecules, we know that there are 4 bonding pairs. And if there are 4 bonding pairs, we can draw the shape we're already familiar with. 4 pairs is tetrahedral. The bond angle, just like methane, is 109.5 degrees. Let's move on and do PCl5. So for this one, phosphorus is in group 5. There are 5 electrons in its outer shell. And there's also 5 chlorines. So my dot cross diagram looks like this. I'm most interested in the 1, 2, 3, 4, 5 bonding pairs surrounding the phosphorus. They are what dictate the shape. So when I draw my structure, I know that 5 pairs of electrons is trigonal bipyramidal. So I've drawn the trigonal bipyramidal shape, and I know from the table the bond angles are 90 degrees and 120 degrees. And now let's move on and look at SF6. Well, sulfur is in group 6. There are 6 electrons in its outer shell. So I draw my dot cross diagram again. I've got 1, 2, 3, 4, 5, 6 pairs of electrons around my sulfur that will dictate the shape. That means 6 pairs of electrons, octahedral, and octahedral, the bond angle is 90 degrees. So much of that is direct from the table. If you're happy with that and you're comfortable with it, you're ready to move on to the next video to look at the more complex shapes of molecules. It's also worth pointing out here that this goes slightly against what you've learnt in the past about covalent bonding, that generally we talk about filling to get a full outer shell. But in BeCl2 and BF3, we didn't have a full outer shell around our central atom. And that can happen. Similarly, in PCl5 and SF6, we had 10 and 12 electrons around the central atom respectively. It's not 8. That's what we call an expansion of the octet. As long as you're aware that that can happen, you're ready and equipped to take on the shapes of molecules questions. That takes us to the end of this video. Thank you for listening and goodbye.